lesson 1 to integers. Then we get to throw some negatives in there. Woohoo! And oh no, you'll do good. Fractions are your friend, no matter what anybody tells you. All a negative number is just a number that is less than 0. As we will probably see coming up pretty quick, we'll probably see some temperatures that are under 0, I bet. Because I think one day our high is like 14, is what they're calling for at the moment. Hopefully they're wrong. But so a negative number is just a number that is less than 0. If you think of a number line like we see here, 0 is just kind of the dead middle, dead center of a number line. And they're mirror images. If you took that number line and folded it on 0, negative 1 and 1 would line up, negative 2 and 2. It's just one side's negative, one side's positive. And so the negatives are opposite of the positives, right? So y'all remember absolute value? Okay, because the definition of absolute value is the distance a number is from 0 on a number line, right? Because absolute value is the distance, that's why it's always positive. Because we can't have a negative distance, right? Or at least not in our plane of existence. Maybe in another universe you can, but not here. And so what we say is like, I'm just going to use their little number line here. So if we had, I want to know absolute value of negative 2. Let me make my absolute value signs a little bigger. Okay? Because the little straight bars are absolute value. And so what that says is I'm going to go over here and look at negative 2. I'm going to say, well, that's 1, 2 spaces from 0. So my absolute value of that has to be positive because it's a distance. It's how far it is, right? Just for giggles, what is absolute value of positive 3? 3, because if I do go here, that's 1, 2, 3 from 0. Okay, makes sense? So whatever is in those absolute value signs is going to come out positive in the end when you take the absolute value of it. Because even if I have, just for giggles, something like 10 minus 7, make it look like a 7, absolute value of 10 minus 7, well, that's telling me it wants the absolute value. What's 10 minus 7? 3. And we already said the absolute value of 3 is 3, right? Now it can, your expression can be negative if it has an absolute value in it, but it will be something like the negative of absolute value of 4. Okay? If that negative is on the outside of the absolute value, anytime you have a negative outside of anything, that means negative 1 times that whatever it is. Okay? Because we said a while ago, if there's not a number in front of a variable, it's understood to be 1, right? That works with absolute values, with parentheses, with brackets, with everything else too. If there's not a number there, it's understood to be 1. And so what we'd have, when you work this out, you'd have negative 1, I'm going to put parentheses. So we took the absolute value of 4, got positive 4, right? So you get a negative 4 for that expression, but the absolute value is not negative just because the negative was on the outside of it. Does that make sense? Let's see if maybe these are cleared up. So fill less than, greater than, or equal to for the following pairs of numbers. So we just kind of want to work these out just to see what they are. What's the absolute value of negative 5? Whoops, quit. Positive 5. Now I have negative of absolute value of negative 5. What's the absolute value of negative 5? That is 5 but I have that negative outside of it. So I have 5 is what to negative 5? It's got to be bigger than. Alligator eats the big one, right? Did your teachers tell you that, or was that just back in the Stone Age? Okay, good. Yeah, a good way to remember. So how about letter B? Is that greater than, less than, or equal to? How come? Because that's good. This is 8, right? So you have negative times 8. So you kind of have the same thing we had a while ago. How about C?
It would be 16
is equal to 16. 16 is equal to 16? What do you guys think? Well, let's work that out. Let's find our, go back to blue. I like the blue. So it's negative of negative 16. Opposite of negative 16 is positive 16, right? Exactly. Actually, multiply it. Yep. Yep. And then, oops, quit. And then absolute value of negative 16 is also 16. So yeah, that guy's going to be equal to. Okay? What do we think about that?
Wait, so why does the negative times the negative equal a positive?
One way we can look at it is negative as a direction. And so, or you can think of opposite. Because this is saying, I want the opposite of negative 16. What's the opposite of negative 16? Positive 16. Now, we haven't talked about multiplying or dividing negative numbers, but whenever you multiply a negative times a negative, you get a positive. Just like a positive times a positive is
so
positive.
Like if it was on a number line and you had like 2 times 2, you're multiplying. The negative 2, which is taking away twice as many as negative 2.
Well, you'd have, it's telling you to do 2 negative 2s, right?
So you're adding 2 negative 2s.
Yeah. Yeah, because you'd have, so there's negative 1, negative 2, negative 3, negative 4, negative 5. So negative of negative 2, or well, we said 2 negative 2, didn't we? Sorry. Always start at 0. Well, that's saying I want negative 2. I want 2 of those. So there's one of them. There's the other one. Okay. Now you're looking at negative of negative 16. Gosh, what's a good way to explain that? This guy right here is going to tell you to reverse that sign. Because I want the opposite of negative 16. So instead of going negative that way, you'd go positive 16 to in the positive direction, because that says opposite of negative 16, which is kind of what we said very quickly up here. The opposite of a number is the same distance from 0. Okay? Is that okay? I heard lost over here. Why are we lost? Where at? Yes. The rule for multiplying and dividing positive and negatives, if you multiply or divide, same signs. It's always positive. So we know, whoops, quit, scoot over. So just for fun, what is 2 times 3? We agree it's 6? Positive times a positive is a positive, right? Now, if I had negative 2 times negative 3, not negative, positive again, because it's like signs. So whenever you multiply or divide like signs, it's always positive. Now, if you do different signs, it's always negative. So if I have, say, -2, we'll change this up to 5. +5, I have different signs, so I know right now I've got a negative answer. My solution is negative. And then just multiply the numbers. Okay?
So do you look at the first? You always
The-
look at the sign, or you always look if it's positive or a negative, and then you look at the other number.
You kind of, because we can only multiply or divide two numbers at a time, right? So say we were dividing -10 by -2. I just look at those, oh, well, they're both negative, so I know my solution has to be positive because they're like signs. And then just do the numbers, whatever they are. So since negative over a negative is positive, then you just do 10 divided by 2, so you know it's +5. Now, if they're opposite signs, like we had right there, say we have a -30 divided by a +6. Opposite signs, always negative, right? And then do the numbers.
Do we have to use a number line for that?
No,
No.
no. That's just to illustrate. That's all. No. Now you may have, yeah, you may have some exercises where you graph something on a number line, but that's just, say, using this guy up here, say you wanted to graph -4. All you do is go, oh, well, there's -4. Oh, I got it graphed. It's kind of like, if y'all remember XY axis, Cartesian plane. Oh, you know. It's kind of the same idea, because say you wanted to graph 1, 1, well, you go that way 1, up 1, so it'd be right there. You're just doing a point either way. And we'll get to that later, but that's just a bad example, sorry. But no, you don't have to use the number line. That's just kind of hopefully to help us remember. Oh, quit that. Undo. Okay. Got to talk to the computer every now and then. It disobeys. So, getting back to order of operations, and we're going to add and subtract. I think we multiply, divide here in a minute. There we go. So we kind of jumped ahead of ourselves a little bit on that conversation, but we'll get there in a page. So add, subtract integers. Just a couple of definitions so you know what the textbook is talking about. If they ask for counting numbers, that's 1, 2, 3, just like you'd count. You don't start with 0 when you count anything, right? You start with 1. So counting numbers, that's what they mean when they talk about that. Whole numbers are counting numbers in 0, so you can't have a 0 for whole numbers. Integers are what we're interested in. And for lack of a better definition, the integers are the positive and negative whole numbers. Okay? They're not going to have any decimals or any fraction. It's going to be a whole number, but it can be negative something. So they're going to come up from negative infinity, -3, -2, -1, 0, 1, 2, 3, and keep going. Okay? So you have two possibilities when you add integers, because now we can have negatives in there, right? One possibility is they're both the same sign. We like that. Nice and easy. If it's the same sign, now when you add and subtract, same signs, you keep the sign. So again, if we have, say, 2 plus 3, +2 plus +3 gives me a what? +5, right? We were taught that since, gosh, first grade or so. I don't know. Maybe kindergarten. They start everything early nowadays. Or when our kids were in school, our son brought home, he was like 7th grade or something, brought home some English homework. I still don't know what a dangling participle is, and I don't really care. Couldn't help him. Had to call his grandma, who's a master's in English. Mama, what is a dangling participle? She rattled off the definition, but I couldn't tell you what it is. But it's just hanging there. It's dangling. But they're backing everything up so much anymore. But likewise, if we have -1, I'm going to say plus -7. Okay? And there's two ways we could write that. Plus and negative and minus are the same stinking thing. This could be written as, let me change colors on that just because. So if we quit, -1 plus -7, I can write that as -1 minus 7. It's the same stinking thing. Plus and negative and minus are the same thing. Point here being is, now both my numbers are negative. And I'm combining, I'm subtracting these, adding, if you want to look at it in this first way. So I know I'm going to have a negative something. So I'm keeping the sign. They're both same sign. Now I just add the numbers. So 1 and 7 is 8, so I get -8. And you can punch that in on your calculator if you have a little scientific, and it will say, yeah, that's -8. But your scientific calculators will differentiate between minus and negative, okay? Because subtract is going to be, well, on TIs, they have a whole bar there. I think it's maybe divide, times, add, subtract, just all in a horizontal line. And then down, so your subtract button is this guy. Your negative is usually just a little negative in parentheses, at least on a Texas Instrument calculator. I'm not sure about the other guys. But I think on your phone, too, if you use your phone calculator, I think it, or does it do plus and minus?
It's only plus and minus.
Does it plus and minus?
The basic is plus and minus, but
Oh, well, the scientific, I think, may have that same notation.
That has a scientific calculator.
Hmm.
There's a scientific calculator app. They do that
there
with.
is.
Oh, yeah, for free. So that's one possibility. You have like signs, so you keep the sign, add the numbers. Okay? If you have different signs, you look at the numbers and go, you keep the sign of the biggest number and then subtract the two numbers. So if we have, say, -2 plus 10. Okay? So I look at that as my answer, positive or negative. Going to be positive because 10 is bigger than 2, so I'm going to keep that positive sign. Now I subtract it. What's 10 minus 2? So I get a positive 8. And your calculator will tell you that. Okay? Similarly, if you have, say, -7, let's do this. Let's do 4 minus 7. I look at those two numbers, I see different signs because 4 is positive. There's not a sign in front of it, understood to be positive, right? So 7 is bigger than 4, so I know right now when I combine these, I'm going to have a negative solution right now. Okay? So what's 7 minus 4? And then I'm going to use your number line real quick, okay? You don't have to use this, but what it would look like on a number line, so there's -1, -2, -3, -4, -5. All right, so we have 4. Well, we're going to start at 0. So I'm going to go 4 in the positive direction because plus and minus are pretty much a direction, and that's all they are, right? So now I'm at 4, but then I got to go 7 in the negative direction. So let's change to red for that one. So I'd have 1, 2, 3, 4, 5, 6, 7. So that puts me at -3. Just another way of looking at it.
There's also like a really easy way to like do that with not numbers but with dots, but you can just put like different colors.
Yeah. Usually black and red is what they, if you use manipulatives. Yep. Okay. So what in the world do we get for A, 3A? Well, let me ask you this. Is our answer going to be positive or negative? I'm adding this time, yeah. You're thinking multiply and divide. So signs are alike, but I'm adding. So I'm going to get a negative. And since the signs are the same, I add the numbers. 2 plus 4 gives us a 6. How about B, positive or negative? Positive. How come? 6 is bigger than 3, right? So I know it's positive. No, positive what? How come? Because 6 minus 3 is 3. Yeah. C, positive or negative? Negative. And I get a 3, right? Why 7? Yeah, I'm going to add them, right? Same signs. How about, what looks good here? How about F? That one looks nice. Positive or negative? Positive. Because 22 minus 10 it gives us a 12. Are we okay with that? Good, bad. This is the quiet side. Quiet side, rowdy corner. I'll come up with something for you guys here in a minute. Confused area. We don't want a confused area.
Confused area, always ask a bunch of questions, which actually helps a lot.
Well, yes, please do. That's why we're here. We're here to take care of it. So simplify sides. A while ago, what we had negative of -16, I think, right? We said that's positive 16. Couple ways we can look at it. You can take opposite of negative, say right here, 5 minus -6. Well, I can think of that anytime you see plus let me try that again. There's not a plus there, is there? Minus a negative, it makes it a plus because it's saying opposite of -6, which is +6. Okay? So you can think of it as opposite. You can think of it as multiplying, which we hadn't talked about yet, but we're going to right down there. Because anytime you multiply two negatives, you get a positive, right? Because we can think of this guy right here as 5 minus 1 times -6, because it's negative of a negative, right? Which still gives us 5 plus 6. Or you can just take my word for it. Anytime you see minus a negative, it makes it a positive, if there's two negatives in a row. Now, this guy up here, I have -2 minus 1. That's what we just did, right? So I know same sign, so I get a negative, and I'm going to add those and get a 3, because there's not two negatives in a row. On this guy, if I go by this rule right here, this makes, I have minus a negative, so that makes it a plus. So I get 5 plus 6, which is 11. Okay? And your calculator will tell you that if you do negative of -6 or minus -6, It'll give you a positive. How about C? Again, we're kind of going what we did in example 2. It's not 2 negatives in a row, so keep sign of the bigger, subtract the numbers. Letter D. Give you just a second on that. Hang on the wall. I think all the trade I saw one. My wife been letting me hang on the wall. That's one of the rules when we got married. No dead animals on the wall. No taxidermy, yeah. Oh, dang it. So what do we get for D?
7.
Well, this is negative 11. That becomes plus 18 because it's minus a negative. So keep sign of the bigger, subtract them. So positive 7. Outstanding. How about F?
12.
Negative 12 or positive 12?
Positive.
We agree?
Yes.
Yes, yes. Sure? Good. Glad you agree. Because since we have minus a negative, it's negative 10 plus 22. Keep the sign of the bigger, subtract them. So we'll get a 12. Okay? Now what we just talked about a while ago, multiplying and dividing, 2 possibilities there. Again, if they're the same sign, I gotta stay by this. You can't hear me if I walk away. Dang it. Same sign, always positive. Yeah, I need to. Opposite sign, always negative. So negative 100 divided by 4, is that going to be positive or negative? Negative, because I have different signs. So negative, and then just do whatever it says. 100 divided by 4 is 25, right? How about B, positive or negative? 7 times 6. Positive. Same sign, always positive. What's 7 times 6? 42. How about C, positive or negative? That's 2 times negative 5. Oops. Two times negative 5, so that's going to give me a negative because opposite signs. 2 times 5 is 10. How about D, positive or negative? Positive. How about E, positive or negative? Neg. And then F, positive or negative? Y'all can do the numbers. Signs, and I about guarantee you this. 90% of the problems you have are going to be because of signs. Got to keep up with the signs. The numbers are nice. I mean, you're adding, subtracting, multiplying, dividing, whatever you're doing, but it's the signs that mess us up more than anything. So always watch your signs. Simplify the following. Now we do a little exponent action. We talked about these earlier, right? What in the world would I get with negative 2 to the 4th? Is that going to be positive or negative, first off? And think about it for a minute. What's that exponent tell you to do? What is the exponent on?
It is on the negative 2.
It's on the parentheses, right? So what that 4th power tells me in part A there is I want 4 of those parentheses. 4 of those parentheses multiplied together. So what this is telling me to do right here is negative 2 times negative 2 times negative 2 times negative 2. It would not matter what is in the parentheses at all if that exponent is on the parentheses. You're going to do the whole parentheses. I mean, you could have something, a nice long expression in there, and you're going to do 4 of them in this case. So now then, with that being said, are we going to have a positive or a negative solution? How come?
Because negative 2 times negative 2 is positive 4.
Okay.
You'll get 2 of those.
Because if I do these two, I get a positive 4. If I do these two, I get a positive 4, don't I? Positive times a positive is a positive, so I get positive 16. Okay? And another way we can think of that is even power. Now, your negative has to be included with the power like it is in part A. It's in the parentheses, right? Even powers are going to come out positive if the negative is included with the power. On part B, we have a little bit of difficulty here. Is that going to be positive or negative? Because what is your 4th power on this time?
Your 4th power is on this one.
That's just on the 2, right? So what this tells me, and if we think of this, that negative in front of that says negative 1 times 2 to the 4th, right? See? Oops, quit. So this is negative 1 times 2 to the 4th. So I can do 2 to the 4th. We saw that was 16 right here, right? So this is telling me negative 1 times 16, which is negative 16. Now your calculator, let me borrow your calculator. It should tell the difference. As we go there, negative 2 to the 4th. We get a positive 16, right? Now, I don't know if it's going to do this one. Oh, it did. Good. So it does. So a scientific calculator will know the difference. So if you punch in, if you want to try this real quick, we'll just do both these on your calculator. Do a parentheses, negative 2, close your parentheses, whatever your exponent button is on the TIs, it's a little, whatever they call it, rooftop, caret, whatever. And to the 4th, and then equals, you'll get a positive 16, just like we did for part A. If you leave the parentheses off, like we did here, and do negative 2 to the 4th, you get a negative 16, because your calculator is programmed for order of operations. It knows the difference. Okay? Good, bad, indifferent? So letter C. Am I going to have a positive or negative solution out of that? Negative, because it's negative 1 times 3 to the 4th, right? So it'd be negative 3 times 3 times 3 times 3. So yes, negative. I think we had that one earlier too. Negative 81. We did. So letter D, positive or negative? Positive, because the negative's included in that power, and I have an even number. So just like A up, A up there, it's negative 3, negative 3, negative 3, negative 3, which negative 3 times negative 3 is positive 9. Yes? Yes. Thank you. Negative 3 times negative 3 is still positive 9 on that side. So positive 9 times positive 9, positive 81. How about E, positive or negative? Negatory, the exponent is not included, so we would get a negative 49. Now I'm going to throw a wrench on you here. Letter F, positive or negative?
It's going to be negative.
Positive.
Oh, okay, good. I got both ways. Who thinks positive? Who thinks negative? Negatives are good, because now I only have 3. I have an odd number. So if we wrote this thing out, we'd have negative 3, negative 3, negative 3, because that negative is included with the power. Well, now right here I get a positive 9, all right, but it's times a negative 3, so that gives us a negative 27. Okay? Are we good, bad? Oh, wait, I'm about to run over time, aren't I? Get excited about talking about numbers. Where are we at? Oh, man, we're so close. Okay, we're not that close, sorry. I tell you what, we'll do this. Today's what, the 20? So start 1 and 22. We'll pick up right there, and then we'll shut this off.